All right. Good morning, everybody. So this is Miss Ingram, and I'm going to be going over numbers 1 through 11 on the study guide. Basically, any question that has just Unit 1. I think Miss Lowndes is already doing the dimensional analysis questions, so numbers 10 through 11 on her video. So actually, we'll probably stop at number 9. So just 1 through 9 with us. All right, 1 through 9. All right, starting with number 1, which expression is equivalent to this right here? And we've got two binomials, and in between the two binomials, I have a subtraction sign. So with this subtraction sign, we're going to distribute it. So that's going to be negative 7x squared. A negative times a negative is a positive, so positive 6x cubed. And then we're going to bring down this first binomial, 4x to the 5th plus 9x cubed. Now, if you notice, we can combine two of these terms together. We can combine our x to the 3rd powers, so 9 plus 6, all right, 9 plus 6 should be 14, right? 14? No, 15. Miss Ingram can't count. 15x cubed. 15x cubed. Right? I cannot combine these two terms together because they have different exponents. So 4x to the 5th power stays the same, and then negative 7x squared stays the same. All right, so this should be what our answer is 4x to the 5th plus 15x cubed minus 7x squared. Now, if you don't see that on your paper, that's because your answer choices are wrong. But I have an updated study guide, so D is going to be my answer. D is going to be my answer. All right, number 2, I still have polynomials here. This time I have a trinomial because I have 3 terms. And I'm going to combine all of my like terms because I have a plus sign right here. So because I have a plus sign, all I've got to do is combine all of my terms. So all of my like terms. So I'm going to look to see if there's any squares here. Any other squares? These two right here. So 5b squared plus 2b squared is going to be 7b squared. All right, now I'm going to eliminate any other answer choice that doesn't have 7b squared, meaning A. So A is not going to work because it has 9b squared. So now I'm going to look at b to the 3rd power. So 10b to the 3rd power minus b to the 3rd power is going to be 9b to the 3rd power. All right, so anything that doesn't have 9b to the 3rd power, I can eliminate. So I'm going to eliminate D. And then the very last one I have are just B's. 2b plus 6b is 8b. And the only one that matches there is going to be B. All right, now number 3 can be a little tricky here. All right, number 3 can be a little tricky. First of all, this should say S and T. All right, S and T. So S and T are the sizes of 2 different animal populations, and S is bigger than T. So we're going to give S and T some values. So S, we're going to say is 5, and I have to make 5 greater than T. So we're going to say T is going to be 1. We have to make sure that this here is true. Is 5 greater than 1? And it is. All right, now I'm going to take these 2 values and I'm going to plug it in right here. S is 5. 5 plus 1 is 6. 5 times T, all right? 5 times T, T is 1. 5 times 1 is 5. All right, now we're going to use these 2 values and we're going to see which one of our answer choices goes together, okay? So 1 is going to be associated with 6 and 2 is going to be associated with 5. So is 1 bigger than 2? Is 6 bigger than 5? And 6 is bigger than 5, so that's going to be okay. Is 1 smaller than 2? So is 6 smaller than 5? No, 6 is not smaller than 5. Is 1 equal to 2? Is 6 equal to 5? And no, it is not. All right, no, it is not. And it is impossible to tell if 1 is bigger than or smaller than 2. And that's not true either, because we put a check mark by number 1. Because 1 is bigger than 2, 6 is bigger than 5, which means A should be our correct answer. All right, A should be our correct answer. All right, the tricky part here is to make sure that you have values, you assign values to these two, S and T or P or Q or whatever the variables are, but you have to make sure that this is satisfied, that S is bigger than T. So when you choose numbers, make sure you choose numbers based on this sign here. All right, number 4, Alicia has a certain number of bracelets. Danielle has 5 less than 2 times as Alicia, okay? So 5 less than, 5 minus, less than deals with minus, 2 times. 5 less than and 2 times, so 2 times. So here we're missing an X, all right? So don't forget that less than also means that we have to switch around the order. So that should be X minus 5, all right? But I also have to have 2 times, in parentheses, 2 times, all right? 2 times. So the only one that goes with this is going to be C. Now, the reason why we had to switch the order here is because of less than. Because 5 came first, that means that 5 is put inside of the back of this parentheses. So you can kind of read it backwards. 5 less than and 2 times. Then we move on to radicals, all right, radicals. So with radicals, we have to simplify this first one, and I'm going to write this one over here. -2 square root 72. So I need to break apart 72 into my factors. What times what gives me 72? Now, if I'm thinking about this, I know 9 times 8 gives me 72. But I can still break apart 9 and 8. 9 can be broken up into 3 and 3. 8 can be broken up into 4 and 2. 3 cannot be broken up anymore. 3 can only be broken up by 3 and 1. 3 is prime, 3 is prime. And 2 cannot be broken up anymore because 2 is prime. But 4 can be broken up one more time into 2 and 2. So if I am simplifying this, I have -2 on the outside, square root 3 times 3 times 2 times 2 times 2. Now remember, don't forget, anytime that you've got a pair, one of them gets moved out. So that's going to be -2 times 3 times 2 square root 2. So I can stop here and I can look at my answer choices and see, okay, do I have anything else that doesn't have just square root 2 inside of my radical? And the only one that has square root 2 ends up being B. Now we can check this. We can check to see if our coefficient right here, -12, is going to be -12 here. Let's think about that. -2 times 3 is -6. -6 times 2 is -12 square root 2. So it does end up being right. But you can actually stop at this step right here to check to see if your radicals are the same. All right, see if your radicals are the same. All right, number 6, what is the product of 4 and 6.5 square root 5? Is the product rational or irrational? So when we think about rational or irrational, if it's rational, that means it's fractional, meaning I can take a rational number and turn it into a fraction. So let's think about 4 here. Can I take 4 and turn it to a fraction? Of course I can. 4 over 1. So that's going to be a rational number. But if I have a radical, anytime I have a radical, it's automatically going to be irrational due to that radical here. So this one's going to be irrational, meaning that my product, when I multiply a rational times irrational, I'm automatically going to get irrational. So I can eliminate any other answer choice here that has rational right next to my answers. So B is not going to work and C is not going to work because they both have rationals here. Meaning I can look at A and D and see they're both irrational, which is perfect. But the differences I have here are going to be what I have before that. I've got 6.5 square root 5 and 26 square root 5. Now, the only one that makes sense here, if I multiply 4 times 6.5, is not going to be 6.5, it's going to be 26 square root 5. All right, so make sure when you're choosing these two answer choices that they fit both of the parts. They fit the irrational part, but they also fit the product part as well. All right, now number 7 is going to be a little lengthy here because we are going to be multiplying radicals. So I'm going to get out a blank sheet of paper because I know that my work's going to be a lot longer. All right, so let me pull this up for us. We had square root 3 times square root 27 times square root 12. All right, now the very first thing I would do is simplify any of the ones that I can. All right, I can't simplify square root 3, but I can simplify square root 27 into 9 and 3. That's going to be 3 square root 3, because remember the square root of 9 is 3. And you can keep simplifying 3 times 3 times 3. Those 3's move out to make it 3 square root 3. And the same thing with square root 12. I can simplify this one into 4 and 3. But really, the square root of 4 is just 2. So that's going to be 2 square root 3. And we can simplify this even more. 2 times 2 times 3. Those 2's move out to make it 2 square root 3. Now, I would have to bring down this whole square root 3 right here, and I would multiply everything. Now, the only things that I can multiply here are going to be, let me get a different color, my radicals, 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So that means that my radical is going to be 27. But then I can also multiply the numbers on the outside, my coefficients. 3 times 2. And 3 times 2 is 6. So then I can now simplify this. Always ask yourself, can this be simplified? And it can. 9 times 3, because we just did this, right? 3 times 3. 3 times 3 times 3. Don't forget that these 3's move out. And I brought down my coefficient right here. Okay, so don't forget about that. So that's going to be 6 times 3 square root 3. 6 times 3 is 18 square root 3. All right, so if we're thinking about our answer choices, my answer choice is here. D is my correct answer. All right, D is my correct answer. This one you had to simplify all the way through because each one of the answer choices has square root 3 as an answer. All right, I'm going to flip the page and we're going to look at 8 and 9. All right, 8 and 9. So which one of these results in a rational number? So we have to think about if each one of these are rational or irrational. The square root of 4 is a perfect square, so that's going to be 2. 2 is rational. I can't simplify 3 square root 5 anymore, so that's going to be irrational. Square root 6, I cannot simplify anymore because if I tried to, that would be broken up into 2 and 3, and that can't be simplified, so that one's irrational. And the square root of 25 is a perfect square, that's going to be 5, so this one is rational. So anything that deals with rational, I need to use L because that's rational, and P because that's rational. So the only ones dealing with L and P are going to be D. Now, one thing that you've got to be careful with here is that you have radicals that multiply. So say, for instance, you had, let's think, square root 5 times square root 5. If I multiply these two, that's going to be square root of 25. And don't forget, the square root of 25 is a perfect square, which gives me 5, which is rational. So sometimes when you multiply irrational times irrational, you end up getting a rational number when it's simplified. All right, this one's irrational, but when you simplify it, it becomes rational. All right, the last one I'm going to do with you guys is going to be number 9. This one's going to be foiling, so I will be using colors again. So foiling, first, outside, inside, last. First, b times 4b. And remember, b times b is not going to be 2b, it's going to be b squared. All right, b squared. So that's going to be 4b squared. B times 5 is going to be 5b. Then I'm going to have negative 2 times 4b. Remember, a negative times a positive is a negative. And then 2 times 4 is 8, negative 8b. And then negative 2 times 5 is going to be negative 10. All right, I can combine 2 of these terms. I can combine 5b minus 8b. And that's going to be negative 3b. 4b squared stays the same, negative 3b, and then negative 10 is going to be my answer. And the only one that matches with that is part C, or letter C. All right, so y'all stay tuned to Ms. Loans' video. Ms. Loans is going to go through these conversions. She's going to do sequences in Unit 3. And then Ms. Tillman is going to start with number 12 and go all the way through, I want to say all the way through 31.